Let's talk briefly about rational numbers. Let's start by looking at the word rational. We see the root ratio. We know a ratio is the relationship between two quantities. For example, the ratio of 3 to 4. We know we can write this ratio other ways as well. We could write it as the fraction, 3 over 4. Let's look at the second representation. This is a fraction. So we can say that a rational number is any number that can be written as a fraction. Now you may be asking, are there other numbers that can't be written as a fraction? Yes, we call those irrational numbers. Here we see the prefix ir, meaning not. Not plus rational means these are numbers that cannot be written as a fraction. So we have two groups of numbers, rational and irrational numbers. Let's take a few examples and see if we can decide which group they belong in. Let's start with 2 over 7. Let's see if we can write this as a fraction. We can write 2 over 7. It already is a fraction. So this is a rational number. Any fraction is a rational number. How about whole numbers, like 6? Remember, you can write a whole number as a fraction by writing a 1 underneath it. In this case, 6 over 1. This is a fraction. This is a rational number. Any whole number is also a rational number. Now how about a mixed number, like 3 and 2/5? Remember, you can turn a mixed number into a fraction. First you multiply the denominator times the whole number, then you add that product to the numerator. In this case, we'll get a 17. We keep the denominator we had from the original mixed number, in this case 17 over 5. Now this is an improper fraction, but that's still a fraction, so a mixed number is also a rational number. Now let's take a look at a decimal. 0.5. Hopefully this is one you recognize. This is equal to a half. This is a rational number. Now, what about a decimal that we don't recognize? Let's look at 0.3892. First, let me show you a way to turn any decimal into a fraction. Remember, we could turn a whole number into a fraction by writing a 1 underneath it. Let's do the same thing here. Now, we can't leave that decimal in the numerator, so let's find the decimal in the denominator after the 1, and let's move both of these decimals together over to the right of the fraction. As we move the decimal in the numerator, we're moving the decimal in the denominator and adding zeros until we get to the end. Now we have 3,892 over 10,000. It's not a great fraction. We can reduce it. This simplifies to 973 over 2,500, but either way it's a fraction, so it's rational. Now try one on your own. See if you can convert 3.26 into a fraction. You should have written a 1 underneath 3.26 and then moved both decimal points all the way to the end of the fraction, and we get 326 over 100. So we are able to write 3.26 as a fraction, so this is a rational number. As long as we can find the end of the decimal, we can write it as a fraction, and it is a rational number. How about a longer decimal? Let's look at 0.3 repeating. This means 0.333 and so on. The 3's never stop. Well, this fraction is equal to 1/3. You may or may not recognize that. I can write 0.3 repeating as a fraction, so it is also a rational number. Any fraction that repeats or has any sort of pattern is going to be a rational number. Let's take a look at another decimal. You may recognize 3.14. You may recognize it as pi. Well, that's not exactly what pi is. Pi is actually much longer. It starts off 3.14159, and then it keeps going. The decimal value of pi never stops, it never repeats, and it never shows any pattern. This is our first example of an irrational number. there is no fraction that we can write that is exactly equal to the value of pi. Next, let's look at this value. This means the square root of 2. This indicates the number that can be multiplied by itself to equal 2. The square root of 2 starts off as 1.414, but then its decimal value keeps going without any repeating and without any pattern. Just like pi, this is also an irrational number. Many square roots are irrational numbers, but not all of them. Let's look, for example, at the square root of 25. What number can I multiply by itself to equal 25? I can multiply 5 times 5 to equal 25. Is 5 a rational number? Yes, 5 is a whole number, and every whole number is rational. However, if we look at the square root of 26, the square root of 26 is an irrational number. So let's review what we know about rational numbers. Rational numbers can be written as fractions. Examples of rational numbers are fractions, whole numbers, mixed numbers, decimals that end, and decimals that have a pattern. And now irrational numbers. These are values that cannot be written as fractions. Some decimals are irrational numbers. Decimals with no end, no repeating, and no pattern. Pi is an example of an irrational number, and many square roots are irrational. Hopefully now you can tell the difference between a rational number and an irrational number. You know what each of them means, and you can list a couple of examples of each.